Okay, good morning, everybody. Okay, we proceed with the previous lecture. Okay, we here we introduce what we call it. I give you example like VLSM example, variable length subnet mask. So normally, what you have to do, okay, for example, dengar tak? Semua dengar tak? Can you hear?
Dengar ada.
Okay, thank you. Okay, for example, given network address a.b.c.d./i. This is a generic notation. Okay, A, B, C, D should be decimal lah. Okay, from for example 192.168 blah 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 lah. Okay, so find VLSM. Okay, step to solve the problem. Number one, you need to define the I subnet of ABC a.b.c.d/i. Okay, I is a prefix, and then secondly, define the host addresses. Okay, in this case, the Haida, what you try to present? Nur Haida, what you try to do? Tolong please don't share anything with this group. I will kick you if you share something. Only myself can share. Okay. Okay. Secondly, we need to define host. Okay. In this case, for subnet P lah. Subnet P mean VLAN lah, VLAN 1 ke or branches. In this case, branches P. Again, for this one C, a.b.c.d/j. J, that means you already do a VLSM. Okay, and also you can define the subnet. Okay, subnet for maybe subnet Q, another subnet lah. Okay, and then of course for subnet Q here, nampak tak? Tak nampak Okay. Okay, for this one for host subnet Q. That means for the subnet it become a.b.g.d.k. That means the number is changing. Okay, the decimal number will changing, and the prefix number also changing, become k. Okay, and then so on. After that, if you do host address for subnet Q, for example Q to P, the subnet changing, the decimal number is changing. After that, for subnet Q, the decimal also changing. Eventually you get subnet for Q's R, and the decimal changing become A, B, H, R, and L. In this case, if you look here, normally AB is fixed. Okay, see AB is fixed. The only changing is this one this area C, D, these two what we call a bitmap changing lah. Okay. So what actually CIDR allow routing? This one classless interdomain routing, CIDR. Okay, CIDR allow routing protocol to summarize multiple network. That means if you have maybe 100 network or maybe you have 10 network, what what CIDR do, they do a summarization for multiple network. That means a block of addresses as a single route. That means, let's say you have 10 networks, maybe network 10.1, maybe network 172 or 173 dot blah blah blah, kan? And let's say you have 10 network, it will summarize to become one route summarization. Okay, that's the function of classes interdomain routing. Okay, what is the features of CIDR? Okay, CIDR deal with routing table explosion problem. That means if we have too many routing table, okay, CIDR we solve in terms of it become one routing table. Okay, network represented by prefix and mask. Okay, pre-CIDR, that means before CIDR happen. Okay, pre-CIDR, network with range of 60 contiguous class C block requires 16 entry. Okay, and then what happen if post CIDR, after CIDR happen? Okay, network with range of 16 contiguous class C block require one entry. That means from 16 become one. Maybe since 60 entry, maybe 16 routing table become one routing table. So the solution is to route according to prefix of address, not class. So in this case, it's a classless, kan? Cluster, right? So it depends on the prefix of address. Okay. 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 CIDR allocation principle. D is based on standard RFC 1518 and RFC until RFC 1520. Okay, RFC stand for request for comment. Okay, this is a standard for internet lah. You can find from you can read the white paper. Just Google and type RFC 1518. It will come out lah. Okay, so what the principle lah? Okay, transit routing domain or TRD. Okay, transit that means you stay for a while temporary transit have a unique IP. Okay, prefix carry traffic between routing table. Okay, the prefix /i or /j whatever carry traffic between routing domain. Prefix carry traffic between routing domain. Okay, interconnecting non-hierarchical cross-national boundaries. Okay, this one most routing domain single home. That mean dual home mean single home. That mean you, for example, the router use only one ISP. For example, you use TM lah. If they say dual homing, that means you use one router, two ISP. For example, you suspect one is time.com, one is Telecom Malaysia. So this process we call dual homing. But for this one, normally they are typically the routing domain is single home. That means use one ISP lah. Okay, search domain assign addresses with TRD, mean transit routing domain, IP prefix. Okay, all of the addresses attached to TRD aggregate into one table entry. That means like I told you, let's say you have 10 network. Okay, that means you have 10 routing table. Eventually, when you do CIDR, it become one entry, table entry. Okay. Right. And then what are the principles? Network topology follow continental or national boundary. Okay. Normally, this CIDR, okay, the network topology follow the continental mean, for example, Asia, Europe, Northern America. Okay. Or probably based on the country lah. Okay, Malaysia, Thailand, Singapore, Indonesia. Okay, IP addresses should be assigned on this basis. That means normally in Malaysia, for example, the body that assign the IP address, allocate a specific range for Malaysia. For example, 103 dot 200 dot 20 dot 30. So maybe something like that. Okay, for others number, for example, maybe 200, maybe is assigned for Singapore. Okay, that's authority lah. Okay, body authority that assign these IP addresses. Okay, implementation for CIDR normally through BGP version 4. 3GP mean Border Gateway Protocol version 4. Okay, this BGP is only used for internet. Okay, for internet. Other than internet, you cannot use BGP. Okay, internet or probably you want to use for a different organization or probably different country. For example, okay, for Malaysia BGP version 4, they have autonomous AS, autonomous system lah. Autonomous system is like their addresses lah. Thailand have their AS. Indonesia have the AS. Mesir, Egypt, maybe Yemen, they have their own AS. However, not necessarily depend on the country. It could be depend on the organization. For example, for example, you work as network engineer at Malaysia airport system, MAS. Flight, the flight, MAS, Malaysia Airline System. Okay, Malaysia Airline System, they have offices overseas. For example, they have in Tokyo, or maybe they have in Seoul, Korea. Maybe they have in Saudi Arabia. Okay, the organization, okay, they can assign their AS number, but they need to request from authority lah. For example maybe MAS in Malaysia they use 100 AS 100. Maybe in Tokyo they use AS 200. Okay, maybe in Egypt they use AS 300. Okay, it can be like that lah. Okay, also it can the BGP can also implement based on the service provider, internet service provider. For example, okay, if you subscribe from telecom, okay, let's say you are using dual home, that means you subscribe at least to service provider. For example, telecom. Okay, maybe telecom assign you AS 300. Maybe Maxis assign you AS 400 in Malaysia. It can be like that. Maybe DG will assign 500. As long as different organization, they can assign different AS lah. That's the function of AS lah. Right. Next, okay. CIDR and VLSM. Okay. So what is the similarity and differences lah? Okay. Can only subnet a subnet that is empty. These is the features. Okay. These two process can only use for subnet that is empty. Okay, CIDR and VLSM not only prevent address waste, but also promote route aggregation. Okay, so this is the benefit lah, CIDR and VLSM. Okay, and then classless routing protocol carry a prefix that consists of 32-bit IP address and bit mask in the routing upgrade. Okay, this is the one of the benefit lah. Okay, right. CIDR and route summarization. Okay, classless interdomain routing and route summarization. Okay, CIDR normally is route summarization. Okay, a supernet, not superman, supernet. Okay, supernet summarize multiple network addresses with a mask less than a classful mask. Okay, what does it mean? Okay, this one network, customer A, one network which is using 0, this one 2.0, this 4.0, 8.0. So you have, for example, in this case, maybe you work as a what we call, okay, for example lah, okay, you work at a multinational company. Let's say you work in Intel, okay, Intel have factory in customer A, maybe their branch lah, branch maybe in India, maybe this in China, maybe this in what we call Malaysia, probably this in Singapore, okay, maybe HQ in US, for example, okay. So you have multiple networks, okay. So what happened? You look here. This is a private IP address. Yes, you can use CIDR in private IP address. Doesn't matter, because this one is Metro Ethernet. We call private list line. You can use that. Okay. Normally you can subscribe like IP VPN. You can subscribe Metro Ethernet, or maybe this is SD-WAN. Okay, SD-WAN link. Okay. So what happened? You have that means you have 4 tables. Okay, table 1, routing table 1, routing table 2, routing table at customer C, and routing table at customer D, because you have 4 network. So what happened? Here ISP 1, for example, telecom lah. Okay, telecom, they will do CIDR and they do summary route summarization lah. So what happened? They just take A and B. Remember, 192.168. This one is class C. 192.168.0.0/20. Okay, they do route summarization. Okay, this one /21, 22, 23, 23. It becomes /20. Summary route and forward to other country lah. Okay, this example lah. Right. So actually, how the process happen? For example, you have 192.168.0.0. This one branch. For example, maybe in India, this one /23, 2.0/23, 4.0/22, 8.0/21. Okay, are all subnet of this one. That means the process is after that, when the router forward the routing table to ISP1, and here in customer B, for example, they forward the routing table to ISP this ISP, same as this. Okay, so what happened in ISP? They will do CIDR. Okay, they will CIDR, and they will cut the route summarization become 0.0/20. Okay. So next is what? Propagating VLSM and SuperNet route require a classless routing protocol because the subnet mask can no longer be determined by the value of first octet. Okay. So what happened after this? This network, they don't know what. They don't know. They only know, for example, ISP2. They only accept this route summarization. Okay, but for this like 0.0, 2.0, 4.0, 8.0, ISP2, they don't know this. They don't know this IP address. The only thing is this router know what is inside /20. ISP2, they don't know, because they want to do a summarization to reduce the utilization of CPU inside the router. So they need to do a summary route summarization. That's the purpose lah. Otherwise, if you carry all the network, the ISP2 become overloaded lah, the CPU. Okay, CPU process or CPU utilization become higher. That's the one of the reason lah for route summarization lah. Okay, longest prefix match. Okay, CIDR impact routing and forwarding. Okay, routing table and routing protocols must carry IP address and mask. Okay, mask means /20 ke /22 ke. Okay, several fast longest prefix matching algorithm are available. Okay, multiple entry may match a given IP destination address. Okay, multiple entry may match a given IP destination addresses. Okay, example, routing table may contain 205.100.0.0/22, which correspond to a given supernet. Okay, see, 22 become 20, 205.100.0.0/20. Okay, which results from aggregation of a larger number of destination into a supernet. Packet must be routed using the more specific route that is the longest prefix match. So the longest prefix match. Eventually, at destination, the prefix number become less number lah. Maybe eventually become /8, /6, /4. Okay, depend on the how many hop lah. Okay. Okay, IP routing protocol. IP routing protocol are characterized by number one, classful or classless IP. Okay, classful or classless IP addresses or routing. Okay, and then static and dynamic routing. For example, distant vector or link state routing metric. So that means depend on the routing metric. Okay, and also distant vector or link state. Distant vector, for example, is EIGRP. Okay, link state, for example, OSPF or ISIS. Okay. Okay, variable length subnet mask or VLSM to conserve and use efficiently the total IP addresses or location. So they make efficient of IP addresses lah. Okay. Route summarization across network boundaries. Okay. So this route summarization, there's benefit lah. One is to reduce CPU load. Okay, CPU load. Secondly, to make algorithm easier to make a calculation. Okay. And then timer. Okay, IP routing protocol. Okay, IP routing provide a mechanism to route packets from different network. Okay, addresses classified as an inter-domain or interior gateway protocol. So IGP and intra-domain or exterior gateway protocol or EGP routing protocol. Okay. Oh, banyak yang keluar, kenapa Ada kelas ke?
Tak.
Tinggal 60 je ni. Yang lain pergi mana? Azim, ada kelas tak?
Saya tak ada kelas. Saya pula tahu apa jadi.
Ya ke? Daripada 109 dengan 60 ni macam mana?
Internet problem kot.
Internet problem? Oh, okay. Okay. IGP for example, OSPF, IGRP, RIP, RIP. Okay. EGRP, BGP only. That border gateway routing protocol, BGP version 4. Okay. IGP is designed to distribute routing information within an autonomous system, okay, like I say, KS, and use the IP addresses. Use the IP address to establish the route, such as RIP, IGRP, and OSPF. This is for IGP lah, macam saya cakap tadi. Okay, what is EGP? EGP is also used to exchange routing information among different AS or autonomous system and depend on a AS number to construct parts. For example, BGP, border gateway routing protocol. So, okay, in this class, we only maybe BGP is very small topic lah, because BGP is normally is for advanced network lah. Normally, we for this class, we only focus on IGP lah. Okay. So, for example, OSPF, maybe IGRP lah. We choose this lah. These two protocol for our class lah. Okay. Okay. Right. Kalau macam itulah kan. Okay, we take a break for 5 minutes lah, because after this we have a new topic lah. Okay, so after 5 minutes we come back. Okay.
Ya, tak.
Alright. Okay. Routing and forwarding. Okay, for this lecture, we focus on the IP routing. Okay, IP routing is the most important what we call knowledge for network engineer. Okay, you should know what is IP routing. Okay. Okay, what is routing? Routing is how to determine the routing table entry. Okay. Okay. How to determine the routing table entry? So you have routing table. So the routing will determine which goes to which lah. Okay. And then routing also carry out by routing daemon. Okay. Routing daemon means inside the system lah. Daemon mean no unto lah. It's like algorithm lah. Okay. Forwarding. What is that? Forwarding is look up routing table and forward packet from input to output port. Okay, this is the function for forwarding. It carry out by IP layer. Okay, forwarding. Okay, router exchange information using routing protocol to develop the routing table. Okay, router exchange information using routing protocol to develop the routing table. Okay. Forwarding table versus routing table. What is the difference between forwarding table and routing table? Okay, forwarding table used when a packet is being forwarded and so must contain enough information to accomplish the forwarding function. Second, a row in the forwarding table contains the mapping from a network number to an outgoing interface and some MAC information. MAC is medium access control information such as Ethernet address of the network. Normally, forwarding table used for switches, layer 2 lah. Normally, okay, not necessary but normally, okay. Routing table is for layer 3 or network layer, okay. So what is that? Routing table built by the routing algorithm. Okay, routing algorithm as a precursor to build the forwarding table. Okay, generally contains mapping from network number to next hop. So okay, this one is from network number to next hop. This one is for forwarding table network number to MAC address. Okay, so different. This is for normally inside the router. This one forwarding table normally inside the switch. Okay. Key role of routing. Yeah. The features, the key role is, role mean peranan dia lah. How to get packet from here to here to there. That means this is the role lah. Okay. Decentralized nature of internet makes routing a major challenge. Decentralized. That means distributed. Okay. IGP or interior gateway protocols are used to determine route within a domain. That means inside the AS. Okay. Exterior gateway protocol or EGP are used to determine routes across domain. It means across domain, for example, different AS. Okay. Route must be consistent and produce stable flow. Okay. Okay. For forwarding, look up routing table, forward packet from input to output port. Normally, like I said, this one is inside the switch lah. Okay. Carry out by player. Routers exchange information using routing protocol to develop the routing table. Okay. Okay, what is the difference between static and dynamic route? Okay. The static route, static routing set up manually. Okay. Do not change required administration. That means static route easy. For example, you want to connect between two router from Kanga to Alustar. So you use static route lah. Why you want to use dynamic? Because only two router. One is in Kanga, one in Alustar. And then you set up the static route. Okay. Work when traffic predictable. And network is simple. So like I said, if you have two router, simple network, just use state out lah. Okay. Used to override some route set by dynamic algorithm. Okay. Used to provide default router. Okay. Default router mean, for example, you have one router. Okay, let's say lah, you configure Cyberjaya. Okay, you want to be sure the route goes to you, right? You just configure, for example, 103.4.5.6, and then the default route is 0.0.0.0. You configure like that. Okay, that means all route will go to default. Okay. What is dynamic routing? Okay, adapt to changes in network condition. Okay, this is one of the features. Okay, use a route that a network routing protocol adjusts automatically for topology or traffic changes. Use a route that network routing protocol adjusts automatically for topology or traffic changes. Okay, calculate route, okay, based on receive updated network state information. So every time they receive the routing table, they will update lah. So this is dynamic routing protocol. Okay. Right. Okay. IP routing protocol are characterized by classful or classless IP address for routing. So classful and classless, you already know. We already learned last previous lecture. Okay, static and dynamic routing. Okay. In this case, dynamic, either distant vector or link state lah. Okay, like I said, EIGRP, OSPF, ISIS. Okay, and also characterized by routing metric. So routing metric means the cost lah. Is it based on bandwidth, based on link, based on preference, based on so many metric number lah. Okay, the metric number mean like parameter lah. Okay. Variable link subnet mask or VLSM to conserve and use efficiently the total IP address allocation. So also it depends on the VLSM. Okay, route synchronization across network boundary and timer. So this we already learned lah. Okay. Okay. IP routing provide a mechanism to route packet from different network addresses. Okay. Classified as an inter-domain or extra gateway protocol (IGP) and intra-domain extra gateway protocol (EGIP) routing protocol. So what does it mean? The mechanism for IP routing, if we route packet different route. For example, one is class A, okay, 10.1.1, and another one is class B. For example, 173.1.1.1. So different network, right? Or it could be 10.1.1, or could to route to 10.2.2.2 pun boleh. Okay, as long as different network. So that's the function of IP routing. Okay, IGP is designed to distribute routing information within an autonomous system (AS), and use the IP address to establish the route, such as RIP, routing information protocol, interior gateway routing protocol or IGRP, and open shortest path first or OSPF. So they want to distribute routing information, okay, to the IP address that establish the route lah. Okay. Okay, EGRP only for internet. EGRP or external gateway protocol is used to exchange routing information, okay, among different autonomous system AS and depend on the AS number to construct paths. For example, BGP. Okay. So remember, IGP distribute routing information. EGRP exchange routing information. So different, distribute, exchange. Okay, different. Okay. AS or autonomous system interior or exterior routing protocol. Okay. Okay. An autonomous system is a collection of network under a common administrative domain. So this is definition of autonomous system. Okay. collection of network under a common administrative domain. Okay. IGRP operate within autonomous system. Okay, look here. This one, for example, is IGRP, autonomous 100, for example. Okay. This one also, this one is AS100, this one AS200. Okay. EIGRP work in this area. Okay. EIGRP connect different autonomous system. So that means if you want to connect from 100 to 200, you require BGP. You require BGP mean EGP lah. This one is function or BGP or EGP. This one function for IGP, and also this one function of IGP. Okay. Jangan tanya pula what is this? This is cloud lah. Okay. Cloud means symbolic for huge large network lah. Okay. Okay, routing metric. Okay, what is routing metric? Routing metric depend on normally or typically depend on for 4 to 6 lah, macam itu. But here I mention you the common one lah. Okay. Okay, number one, bandwidth. Okay, the data capacity or data rate of link, which is the connection between two network equipment. So normally we call data capacity or data rate, something like that. Same terminology. Okay. And then second is delay. Okay, the length of time required to move a packet along each link from source to destination. From source to destination, for example, you want to do routing between two routers, one maybe in Butterworth, one in Ipoh. Okay, so the delay means the packet along each link. That means the packet travels from Butterworth, Penang to Ipoh. That is the delay. How much the delay? Maybe 100 millisecond. Okay, maybe 10 millisecond. Itulah. Hop count. The number of router that packet must travel through before reach its destination. Okay, for example. Okay, you have 3 router. Okay, for example, one in Kanga, one is Butterworth, one in Ipoh. Okay, hop count mean you have 3 hop count lah. One is in Kanga, one is in Butterworth, one in Ipoh. So that's we call the hop count, which is the number of router that packet must travel through before reaching its destination. Okay, for example, macam ni lah. Okay, you have how many hop from here to here? Or from here, okay, here to here, how many hop? You have 1, 2, 3, 4, 5, 6. Okay, berjalan ni lah, for example. So you have 6 hop. Okay, macam tu maksud dia. If you want to travel from here, okay, to here, you have 3 lah. 1, 2, 3. Okay. Cost, okay. An arbitrary value assigned by the network administrator, okay, usually based on bandwidth, okay, administrator preference or other measurements. So cost you can set inside the router, either based on bandwidth or maybe under administrator preference. Preference is number lah, maybe 200, maybe 300, maybe 1000. It's a preference number lah. Or other measurement, or maybe in the router probably. Okay, router, for example, normally in the market, in the industry lah, I can say 90% or 95% router in this world using Cisco lah. Okay, others probably Juniper, probably Huawei. Okay, for the router market, Cisco is the majority that industry use lah, because of the robust lah. Okay, and Cisco router is the first router built in this world lah, maksudnya yang first. Okay, first. Like other brand like Juniper ke Huawei, whatever brand lah, that one is just competitor lah. Okay. Okay, static route. Okay, static route lah. Ada apa-apa nak tanya ke? Anything want to ask before we proceed? Ada siapa nak tanya? Ada berani tak tanya? Tak ada.
Belum ya.
Apa dia? Blur lagi?
Belum lagi.
Oh, okay, static route. Okay. Configure unidirectional static route to and from a stub network to allow communication to occur. So, for example, okay, you want this router A, for example lah, maybe in Cyberjaya, okay, maybe here in Putrajaya, example, So this one dia cloud lah, okay. This maybe they have host in Putrajaya, for example. Okay, so what happen? Static route is you configure, for example here lah. This one is interface serial 0/0/0, okay, and the IP address is 172.16.2.2. Okay, this one apa? This one is private IP address lah. Actually this one okay, this one is for purpose of academic lah. Okay, we can use 172.16 if this one is private link. Private link. If internet link, you cannot configure because router don't understand. Okay, maybe this one is like list line lah, okay, or metro ethernet lah, maknanya private link. Okay, so you configure 172.16.2.2 and another one you configure in Putrajaya 172.16.2.1, okay, .2.1. Okay, if you want to configure two router, use static route je lah. So from two or from a stub, see this one is stub network lah, and inside here 16.1 different network, .1 is for local area network lah. Okay, right. Another protocol we call RIP. RIP is a routing information protocol. Features maximum is 16 equal cross paths. Default is 4. Okay, what does it mean? Normally maximum for RIP protocol is 16 router. That means 16 router or maximum lah, or we call 16 hop lah. Okay, maksudnya ada 16 router je boleh configure. 17 cannot configure. The maximum limit is 16 lah. Normally default is 4. Okay, 1, 2, 3, 4. Okay, hop count matrix, select the parts. Okay, select the parts depend on the maybe bandwidth, maybe routing table, delay, maybe hop count, maybe cost. Okay, so in this case, for example, this is old network lah. They're using 19.2 kilobit per second. Nowadays, no more 19. Minimum pun, I think, if I'm not mistaken lah, maybe 100 meg lah. 100 megabit per second lah minimum. This one is just for purpose of academic lah. So this one E1 E1 link mean like 1 meg lah, 1 meg link. So this one route update every 30 seconds. So every 30 seconds the database will update. The router will update to database. So RIP normally used for simple network, or I can say nobody use lah RIP currently because too simple. Okay, what is the difference between RIP version 1 and version 2 lah, comparison. Okay, routing protocol for RIP 1 is old one. Okay, sekejap sekejap. Okay, so RIP, actually this is a classical routing protocol lah. Okay, RIP 1 version 1 only used for classful only, but RIP 2 version 2 they support classless. Okay, for for like RIP 2 version 2, version 2 support VLSM, support subnet, subnet mask along with routing update, support restart, multicast. Okay. Okay, for version 2, the standard is this one, 1721, 1722, and 2453. Ni RFC lah. Okay, for version 2, you can do a route summarization and also authentication support. Okay. Okay, link state routing protocol. Okay. Sekejap, ada orang call. Okay, link state routing protocol. It is another protocol for routing, for IP routing. Okay, after initial flood, passes small event trigger link state update to all other routers. So, for example, this one they will flooding the information, routing information. For example, this one goes to here, goes here, and goes here, like macam broadcast lah. Okay. Okay, normally here they have topological database, okay, and short pass first algorithm. Yeah. Okay, so this one is structure of link state, and this one is SPF algorithm. Okay, so what happened? The routing table become like this structure lah, like tree lah, short term pass first tree. Okay, right. So what happened? Link state advertisement LSA will update for all routers. Okay, for example R1, R2, R3, R4 lah. Okay, so so what happened? The process is link state database like this one, and use Digitra algorithm. Digitra is the name of person that invent the short pass first. Okay, inventor. Okay, nama dia Digitra. Okay, so after that, it convert to the SPF3 shortest path first tree like this one, and do a calculation. And then after that, it will determine which is the best parts. So after that, it will put inside the routing table. Routing table ni inside the router lah. So for example lah, okay, from Kanga, Rosta, Sungai Petani, Batu. So or the router for these branches, they will update lah. The LSA update lah, the function tu kan. Router recognize more information about the network than their distant vector counterpart. So this is the benefit lah. Okay. And then neighbor table, that means the next router, also known as the agency database. Okay. Topology table refer as LSDB, link state database. Okay. Routing table also known as forwarding database. Okay, so you inside the link state protocol, they have 3 tables called neighbor table, topology table, and routing table. Okay, topology table normally we call link state database. Okay, each router has a full picture of topology. Okay, so for this protocol, all router has the same information for all the routing table lah. Okay, link state routers tend to make more accurate decision. Okay. So what is the benefit and drawbacks of link state routing? That benefit means the pro lah, kebaikan lah. Drawback is keburukan dia lah. Okay. Okay, the benefit for the link state routing, fast convergence. That means changes are reported immediately by the effector source. So that means, let's say you have let's say you have this one kan, Kanga, Alustar, Butterworth, Ipoh. Let's say lah in Alustar, router down, or maybe there's a link problem here. Kan? So what happened? All the router will get all information say that a router in Alustar down. Okay, and that means the link state down lah. Kan? So you get all the information for all router connected to this topology. Okay. Robustness against routing loop. So the good thing about link state, they prevent the routing loop lah. Okay. So router know the topology, link state packet are sequenced and acknowledged. Okay. Hierarchical network design enable optimization of resources. So the design is very hierarchical, easier to design, and sometimes it's scalable. Okay. Alright. What is the drawback for link state? Okay. Significant demand for resources. That means memory. Router memory very extensive lah. High utilization because you need to calculate 3 table lah. Okay, agency mean neighbor table, topology table di LSDB database, and forwarding table. So memory quite high lah. Okay, and then CPU load very high for link state because digital algorithm can be intensive, especially when there are many instability. So if they have a instability in the network, the CPU load very high lah. So you require very high power CPU for this routing protocol. But OSPF is a popular among industry lah, popular IP routing lah. Normally we use CPU, we use OSPF rather than others routing protocol lah. Okay. Requires very strict network design. Configuration can be complex when tuning various parameter and when design is complex. Okay. So configuration, of course lah, you need to know the configuration for OSPF. Very complex but interesting. Okay. For me, I already configure most of my experience in the industry. I configure OSPF. Okay, OSPF in the Cisco router. Okay, I work in, for your information, I work in industry more than 15 years. Okay, I from industry. Okay, I design a lot of network. in Putrajaya, in Sabijaya, in University, Air Force, okay, Police Diraja Malaysia, TUDM, a lot of organisation, okay. So all the organisation, right, have their own preference design lah, okay, but most of them using SPF lah, okay, right. More than 15 years in industry and of course in lecture lagi lama lah, okay. Okay, element of routing techniques, okay. So this is the routing technique number 1. What is the element? Performance criteria. When you want to design the routing, you need to take account of performance criteria. For example, a number of nodes. Number node is number of router lah. Inside the node for example, node means tempat lah. Okay, location. For example, Kanga, Ipoh, Cyberjaya, Putrajaya, Johor Bahru, Sibu, okay, Miri. That is a nodes. Number of nodes. Okay. Cost mean not harga. Cost mean is it what is the preference of router? For example, based on bandwidth or based on number or based on loop, whatever lah. Okay. Delay and throughput. This is performance criteria. You need to take care of this parameter. Okay. Decision time. Okay. Packet or datagram or session, which will skip. Okay, that means this decision time, setup time. This is setup time. Okay. Decision place. Each node, you want distributed or central node, centralized or originating node source. That means it is where you want to start the the router. Which router you want to configure IP routing. So this is the criteria you need to take care lah. Okay. Network information source. Okay. Non-local adjacent node, nodes along route, all nodes. Okay. Right. Network information update timing. Okay. Continuous. Okay. Periodic, major load changes, topology change. So this is network information lah. Okay. Update timing, the hello time, for example, kan. Okay. Routing algorithm requirements. Responsiveness to changes. Okay. Topology or bandwidth changes, congestion. So this one you need to take care. Okay. Rapid convergence of router to consist set of route. Freedom from persisting loop. So this is responsiveness lah. Sensitivity to the changes of the topology. Okay. Optimality. Okay. Resource utilization. Path length. Okay. Robustness. Okay. Continuous working under high load. Congestion. Okay. Fault. Equipment failures. Incorrect implementation. Okay. And simplicity. Okay. Efficient software implementation, reasonable processing load. Okay. So this is all this one is criteria for routing algorithm requirement. Okay. Kita habis pukul 10 kan. Okay, masa lagi. Okay, shortest path algorithm or SPF or SPF. Okay. Digital algorithm compute a sync tree on the graph. Okay, so for shortest path algorithm, shortest path algorithm, then the algorithm used for this we call digital. Digital is the name of person that invent this algorithm. Okay. Each link is assigned a non-negative weight or distance. Okay. Relate distance to other nodes using weight of one give paths with fewest hoops. Okay. So what's the algorithm do? Okay. Okay. So this is the computation. Okay, computation. That means each link assigned with weight, relate distance, and using weight of one give path with fewest hoop. That means the shortest lah. The fewer hoop mean lagi pendek lah. shortest lah, we will go. Okay, what the algorithm do? Start with sync. Sync means source lah. Okay. Set distance and other node to infinity. Okay. Sync means source. Shortest path is the one with lowest total weight. Weight means the cost lah. The cost. The cost lah. Pick the lowest distance node. Okay. Add it to the sync tree. So inside the algorithm lah. So this is what happened inside the algorithm. Okay. Repeat until all nodes are in the sync tree. So this is how the algorithm work. Okay. Okay. Next, find shortest paths from given source nodes to all other nodes. Okay. Develop paths. Okay. Develop paths in order of increasing path length. Okay. Algorithm run in stages. Okay. Each time adding node with next shorter paths. Okay. Algorithm terminate when all nodes have been added to T is time lah. Okay. So this is how the digital algorithm work lah. This one very important for your final example. Okay, so this is graphical visualization lah. This is what happened to digital algorithm method. Step 1, okay, initialization. Okay, T time equal to S, okay, set of nodes so far incorporated, and ln bracket n equal to W bracket S and N for N not equal to S. Okay, N is node lah. Okay, W is weight, S is sink or source. Okay, initial paths cost to neighboring nodes are simply link cost. Okay, step 2, get the next node. Okay, find neighboring node not in T with least cost paths from S. Okay, incorporate node into T. Okay, also incorporate the edge that is incident on that node and a node in T that contribute to the path. Okay, this one you need to remember lah. Okay, this is algorithm. Okay, fixed algorithm. You need to know the step. Okay. Okay. L bracket n equal to minimum bracket L is least cost function of x plus weight function of x n for all n not subject to t. If latter term is minimum, parts from s to n is part from the s to x concatenated with h from x to n. Okay, so actually this one is the remarks lah. The remarks of the algorithm. Cukup lah. Kita bagi satu example lah. Okay. Okay, digital algorithm example 1. Figure 1. Figure 1, where is that? Okay, figure 1. Okay. So this is the figure lah. Node 1, node 2, node 3, node 4, 5, 6. Ni umpama this one like place lah. Okay, Cyberjaya 1, Cyberjaya 2, Putrajaya 1, Putrajaya 2, KLA, nilai, for example. This is not main router lah. So this router, all these location are connected to this fiber optic lah. Okay, this is fiber optic. Okay, fiber optic. So what is the question? Figure 1 illustrates a network in which the two arrow lines between a pair of nodes represent a link between these nodes, and the corresponding number represent the current link cost in each direction. Okay, the shortest path, okay, fewest hops from node 1 to node 6 is 136. Okay, for example, you have node 1. Okay, cakaplah mana-mana location lah. Node 1, node 2, node 3, node 6 lah. Okay, 4 and 5. Okay, so what happened? The shortest path or the fewest hope from node 1 to 6, they said 136. 1, 3, 6, the shortest path. 5 plus 5, 10. Okay. So this is the shortest path, 136. But the least cost path is 1456. 1, 4, 5, 6. 1, 4, 5, 6. Okay, 7 plus 1 plus 4. Okay, this one. So this one. So macam itulah. Okay. Okay, never mind. I think we stop here lah. Okay, because if this one nanti you pening pula kan, banyak pula kan. Faham tak ni? Tak faham next class lah. Okay. Okay. Okay, listen all Okay, Monday kita cuti kan? Betul?
Ya doktor.
Okay.
Ya doktor.
So as we promised last week, last week last Sunday kan, we want to do class for tomorrow night. Boleh tak? Tomorrow night. Boleh ke tak boleh? Ke ada nak celebrate? Ada siapa-siapa nak celebrate Christmas ke malam esok? Anybody want to celebrate Christmas tomorrow night? Okay lah.
Rasa ada. Ada kot rasa.
Ada siapa? Awak? Siapa?
Saya tak lah doktor.
Okay. Macam ni. Tomorrow class is not compulsory lah. Because tomorrow I want to do like tutorial. So siapa-siapa nak join, okay, no problem. For those are not free, tak join pun tak apa. But this tutorial is basically I want to focus on the final exam and ni lah, final exam and test, something like that lah. And then this week I will upload the assignment 1 assignment 2 So you need to submit now. You need to submit before 3 January. Sebab saya nak masukkan dalam sistem markah. Because I want to put the marks inside the system lah. Okay. So you need to submit by very easy assignment lah. Okay. Maybe tomorrow ke macam tu. Tomorrow night ke I will upload lah. And this week I will upload the assignment 2. So this assignment is an individual lah. Okay. So I hope you can check at Google Classroom for assignment. Okay. You submit online lah. Okay. And then for the test actually we need to complete the test 1 is this year tau. Okay. So macam mana ni? Kita nak buat macam mana? 5 apa? Ayah, makan miss lah. Okay, never mind. Focus on the test 1 tu bila kita nak buat? We need to do physical tau. Physical. But we need to do by 6-7. Kalau kita buat 6 hari bulan, selalu you ambil test kat mana? You buat kat mana?
Selalu buat test kat DK.
DK juga? DK meniru lah gitu. Kan?
DK satu besar sangat lah.
Ya ke? Saya buat ke DK Saya tak suka sangat DK ni. Buat dalam kelas lah. Kelas dekat ni. FKTM tu ada table tau. Lagi senang lah, macam dewan peperiksaan. Tak apalah, nanti preference tu pada kelas lah. But never mind. Test, cuma saya nak pilih tarikh dululah. Bila you nak buat test ni? Kita kena buat cepat ni. Actually because next year kita dah habis kelas tau. Maksudnya saya tak ajar lagi tau. Maksudnya the next lecture will be Associate Professor Dr. Fazira. They will teach layer 6 and layer 7 lah. Presentation and application. So we need to complete this one, the network layer by next week lah. Maksudnya kita ada Isnin dah cuti. Betul tak? Isnin cuti.
Ya.
Jumaat last. Dah tak ada lagi. Sekarang berapa bulan 23
Kita nak buat malam ke ataupun petang?
Apa dia? Test?
Ya.
Test malam. Kita buat malam. Takkan buat siang lah. Siang lecture mana boleh kacau.
Kalau malam hari Khamis atau Rabu okey juga.
Berapa hari bulan?
28 atau 29.
Wish. Oh iya ke? 28, 29.
27.
Oh, hari 3
Oh.
28, 29 masa terdekat ni tak sempat pun nak study ni. Saya rasa macam next week kita fokus siapkan assignment lah. Boleh? Sebab macam saya cakap assignment ni sebab saya kena masuk dalam sistem secepat mungkin tau. Untuk ni lah. So, the markah tu you takkan tahulah. Cumanya kena masuk dalam sistem. So, I suggest lah kan. Macam ni. Why not we focus on assignment 2. Okay. Assignment 2 is very easy lah. Very easy. Okay. We need to submit the assignment 2 paling lewat 31 lah paling lewat. 31 tu hari Sabtu malam. Sebab satu hari bulan tu dah satu cuti, satu lagi dia dah next year, tak boleh. Kan? Boleh tak? So I will upload the assignment. InsyaAllah lah by siapa ni soalan dia? What is this? First week next year kan. Okay, we do one by one you follow me, okay? Assignment 2, the deadline is 31st of December. Okay, the deadline. Right? 31st December deadline. Okay. My plan for assignment for test I prefer during first week lah. Okay, first week maybe 5 of January ke 6 ke, ataupun kita buat waktu weekend lah, tapi malam lah. The important thing is the test is at night. I don't want to interrupt your lecture lah during the daytime lah. Okay, anything I will update I will discuss with Hazim. Okay, I will discuss with Hazim, and after that I will inform you lah what is the suitable date. Okay. So by the way, tomorrow, okay, if you have free time, you join 8:30 Saturday 8:30 Saturday. I write here. Okay. Tomorrow is 24, right?
Yes, ada.
Okay. Class 9. Basically tutorial lah Okay. Tomorrow is 24 for December. I'm 8:30 boleh tak? 8:30 PM malam. Okay, boleh?
Boleh ada.
Boleh.
Kita banyak ni. The problem with us, most of our class is Monday. So Monday most of us cuti. So agak susah lah kan. Okay, thank you everybody, and have a nice day. Okay.
Okay, Doktor.
Assalamualaikum.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.